Okay, these notes are titled Net Ionic Equations. Okay, an ionic compound will break up or dissociate into its ions when dissolved in water. For example, when you dissolve table salt, so we're going to take NaCl, and you dump it in water, which is what that aqueous means, or you can write it like this, but you're dumping it in water, it dissolves. If you'll notice, it disappears. It's no longer chunks. Well, what's happening, it's actually dissolving into sodium ion and the chlorine ion. Okay? Same with any kind of ionic compound. You put any ionic compound in water, if it dissolves. Now, some of them do not dissolve. Some of them are insoluble in water. But if they are soluble in water, that means if they dissolve, then they break up into their ions. Let's look at HBr. We're going to dump that into water. Okay? Now, here's the thing. We have to figure out what the ions are. So we have an H and a Br. So you're going to have to use your periodic table for this. Now, if you look up H is in column 1. It's in group 1. So it's got an H plus is the ion. Okay? And then Br is also a -1. So on these, I should have put the plus in there. On these, you're going to have to either look on the periodic table or you're going to need your polyatomic ion chart. You have to find what the charge is on them. You're going to have to look them up. Okay? Okay, when you're writing ions, so you're breaking up a compound into its ions, any subscripts that are on elements, we're not talking about polyatomic ions, but on elements, okay? Or parentheses subscripts, you know, where you have parentheses and then you have that little subscript outside of it, those numbers become coefficients, and those are the big numbers in front. So let me show you. So for example, we have MgI2, okay? We're going to stick that in water. When we do that, we get, now we know that Mg has a +2 charge, but there are two I's. So it's going to be 2I with a minus charge. Aqueous, okay? So there are two I's, because this really is Mg with an I and another I. So we've got to figure out, you know, how many there are. So it might even help you to draw the pictures first. It's an Mg with two I's. And then bring them over to the right-hand side so you can see what they are. So like here, this is one Mg with two I's. And then just put the charge on, you look up the charge on them. Okay? So let's try that again. Let's try another example. Okay, for example 2, we'll do H2SO4. Now that's sulfuric acid or hydrogen sulfide. Now when we put it into water, now let's draw the picture first. So it's an SO4 with two H's attached to it. So I know that it's going to be two H's, and H's have a plus charge when you look them up, and then one SO4. Now if you have your polyatomic ion chart with you, you find that it's a -2 charge. Okay? So there's two H's and one SO4. Really, I think drawing the pictures is going to be the best thing for you to do. Now, how did I know to keep the SO4 together? Well, I recognize this as a polyatomic ion. So you're going to have to be able to recognize the polyatomic ions, unfortunately. So if you see more than two elements, so if this one had 3, you know a polyatomic ion is involved. Okay, let's try another example. Let's try NH4-2S. We're going to dump this into water. Now, first I'm going to draw this. It's an S with two NH4s attached to it. So I know that there are two NH4s. Now, when I look up on my polyatomic ion chart, I find that NH4 has a +1 charge. And don't forget the aqueous on the side, because if it dissolved, that means each ion is dissolved in the water and is aqueous. Now S, I look up on my periodic table, okay, it is in group 16, which has a -2 charge. Okay? So let's try one more. Okay, so let's try Fe2O3, which is rust. So we're going to somehow dissolve that into water. Now, I'm going to draw a picture of it first. So I've got an O and an O and an O with an Fe and an Fe. Okay, so I've got two Fe's. Now, what about my charge? If I look it up, remember, it's one of the metals, transition metals. So when we name these, you had to know the charge anyway. So if we look at the Fe2O3, we cross back up. So this is iron 3. Remember how to do that? So you got to kind of remember how to name those. This is why in the beginning of this unit, we went back through and practiced naming as well as making formulas from names. So this one is iron 3 oxide. So now there are 3 O's, and O, when you look on the periodic table, has a -2 charge. I know it's kind of confusing. This will get easier as we practice, okay? So hopefully you get all this. Now let's look at net ionic equations. Okay, double replacement reactions always occur in water, which means both reactants are aqueous. So they've both been dissolved in water. So there's 4 different ions floating around, but one product will be a precipitate. Now, if you remember, precipitate is something that falls out of solution. It's no longer dissolved in water. Now, a precipitate can be in any form or any state. It can be either a solid, liquid, or a gas. Just cannot be aqueous. It cannot be dissolved in water. Well, that's what a precipitate means. It comes out of water, okay? Now, there are 3 types of ionic equations. So 3 types, actually 2 types, sorry. My bad. 2 types of ionic equations. Can erase that. Put 2. So 2 types of ionic equations. There's the complete ionic equation. Now this one shows all of the ions that are involved. Okay? Shows all of the ions that you put in. So it shows the ions of the reactants and the ions of all the products. But you really don't need that, okay? We're going to look at the net ionic equation. Now, if you remember, the word net means basically it's just what's going on. Okay, so the net ionic equation shows only the ions that make up the solid or liquid product or gas product. And then spectator ions are also involved. So let me do a little bit of definitions on the next slide. Okay, so let's look at our definitions. We have the complete ionic equation, which shows all the ions in the reaction. Then we have the net ionic equation, shows only the ions that make up the precipitate. And by the way, that's the actual reaction that's going on. Okay? The other 2 ions are called spectator ions. They're the ions that do not participate in the reaction. In other words, they don't make up the precipitate. So they're just kind of floating around going, hey, what are you doing down there? You're reacting. Okay, that's pretty cool. You go on. I'm just going to sit here and float around and do nothing. They don't do anything. Okay? They just made up a part of the reactants. So they kind of carried, you could think of them as carriers. They carried in the ions that are doing the reaction. So they kind of carried them in, and then they just kind of sat around and floated around and said, oh, hey, have fun. So they didn't really participate. So let's look at this. Okay. For this one, this is a reaction. You have silver nitrate, which is aqueous, and you dump it in with some sodium chloride in solution. Okay. Now what's going to happen is silver chloride is going to drop out of solution. Precipitate. If you remember from the demonstration the other day, we had lead nitrate and we put in potassium iodide, and then that yellow stuff, remember the yellow solid that appeared? That was the precipitate. That was lead iodide. Okay, that would be called the product. So here, this precipitate is called the product. The Na and NO3 kind of did nothing. So I'm not going to write the complete ionic equation. We don't have to know the complete one. The complete ionic equation would be taking everything. Well, here, I'll write it, but don't write it down. You don't have to copy this. I just want to show you what it is. So your complete one would be this. So you have your silver plus your nitrate, okay, plus your sodium, plus chlorine, Oh, that's a plus, by the way. Yields. Now, what you're going to notice, since it's a solid, it is not aqueous. We do not break apart the solid. Okay? And then you also have sodium and NO3, nitrate. Now, as far as the reaction is concerned, we only care about this side. We don't really care about that side as far as labeling everything. So your task would have been taking this initial equation and writing the net ionic equation. Okay? Now, to write the net ionic equation, we just have to be worried about this precipitate here. So I'm going to break this precipitate up, okay? So I know it started out with Ag, okay? Oops, that's an A, aqueous, and Cl minus. Okay, that's AgCl broken up. Now remember, that's why I showed you how to do ions in solution. Now, if you were really to stick silver chloride in water, it's not going to dissolve. But the two ions were from the previous, were from silver nitrate and sodium chloride. So these are the two ions that are involved. And when they get together, they form AgCl. So there's your net ionic equation. It's telling you exactly what's going on. Now, the other two things, the NaNO3 gives rise to your spectator ions. Okay, so you have some spectator ions here, and they would be Na plus and NO3 minus. Okay, so pretty easy. Let's try another one. Okay, this is what we did the other day. This is what we did with when I was doing the demos. We this was clear, the potassium, the lead nitrate. Okay, remember that was the first clear solution, and then I used a dropper to drop in the potassium iodide, and this yellow, this is that yellow solid that you saw. Okay, so the only thing I'm concerned about, I don't care if you can write the complete ionic equation. You don't have to. So I want to know what's the net ionic equation and what are the spectator ions. So we're going to write down net ionic equation. Now I'm not going to worry about the other stuff. The only thing I'm worried about is the PbI2. So it's lead. We'll worry about the charge in a minute. And two iodines. Okay? Gives me lead iodide. Now we got to go back and add the charges in. Okay, if you look on the periodic table, iodine has a -1 charge. Now lead is a transition element. It has more than one charge. So we look at that too. Remember, crossing back up. So this is going to be lead plus 2. Okay, so that's our net ionic equation. That's it. Nothing more. Now as far as the spectator ions, these are your spectator ions. Okay, so let's take it apart. They're potassium and NO3, which is nitrate. You don't have to put the big 2 in front. You can say 2K plus and 2NO3, but don't worry about it. It's just that. So it's pretty easy, I think, anyway. Okay, so I guess that's about it. If you want more practice, we'll do some more practice tomorrow or Tuesday in class. I'll go ahead and we'll do warm-ups in the beginning. We'll do taking apart them and then doing net ionic equations, spectator ions. So everybody have a good weekend. Bye.